Welcome, Hornets. I'd like to talk to you a little bit about higher degree polynomials, which is our section 2.2 from Honors Pre-Calculus. And this is dealing with polynomials. Now, polynomials have very, very clear characteristics. First of all, polynomials are always smooth and continuous. Smooth means that there are no sharp turns, which we call cusps. Continuous means that there are no gaps. There's no jump like we see in the greatest integer function. There are no vertical gaps that are created by piecewise functions or asymptotes that are created by rational functions where there are omissions from the domain. That means that for all polynomials, the domains are all from negative infinity to positive infinity, no matter what. And this is a characteristic of all of them. So we can rely on that. In fact, as we're graphing them, we have to rely on it. The second thing to be aware of is that depending upon the degree of the polynomial, will determine the shape. Not only is it determining the shape, but it's also determining what happens at each end, at negative infinity and at positive infinity. For example, when we talk about y equals x, this is a linear, it is odd, and therefore, when I'm graphing it, an odd function that has a positive leading coefficient. Leading coefficient is a value, some integer, that is in front of the highest power of x. Now, with a leading coefficient that is positive, like positive 1, positive 2, positive 3, we will always see a shape of our line that is going to move from the third quadrant to the first quadrant. And it has no choice. A cubic, as you have already seen, creates this smooth curve. And the smooth curve approaches the origin, cuts through straight, and then continues up. A fifth degree polynomial is going to create a longer flat segment. So it's going to come down real quickly. It's then going to cruise along the x-axis a lot longer as it cuts through. It's now in the first quadrant. It reaches a point where it then goes up. Now what you'll notice is my lights have just gone off. This happens every 15 minutes, and we're just going to keep going as if it didn't happen. All right, so hopefully you don't get too disoriented. You should be able to see me clearly, and you should be able to see the screen in front of you. So notice all powers that are odd for polynomials that have a positive leading coefficient will always move from the left down below in the third quadrant at negative infinity, and then move to the positive infinity on the y-axis in the first quadrant as the x values continue toward positive infinity. Okay? This is what we refer to as our left and right end rules. What's happening on the right side at negative infinity, at positive infinity, and what's happening on the left side at negative infinity. Okay? Quadratics, x to the fourth or quartics, sextics, octics, dodecics, even powers, they do something slightly different. Remember that a quadratic, x squared, is going to touch the origin, and it's kind of like a bouncing ball. It's going to immediately turn around, hit, and then go back up again. This forms what is referred to as a tangent to the x-axis. Higher degree polynomial, so if this is an x squared, a higher degree polynomial is going to go faster towards the x-axis, cruise along, hit the tangent, and then at some point zooms very quickly. The faster it reaches toward the x-axis, the higher the polynomial degree, and then the fastest it exits. Okay? This creates kind of like a bowl shape. The flatter the bowl, the higher the degree of the polynomial, and it will always be even. So that means that we have our x squared here. This would then be x to the fourth, followed by x to the sixth. And we can see our left end behavior rises to the left and rises to the right, as opposed to the odds that we saw a moment ago, where they fell or fall to the left and rise to the right as their left end and right end behavior. So if you're ever asked, what is the left and right end behavior, always look at the highest degree of the polynomial. Then look at the coefficient. If the coefficient is positive, you know that it's going to follow our standard shape. Highest power is even, they both open up. If the highest power is odd, it's going to fall to the left and it's going to rise to the right. Now, because of what happens with a negative coefficient, this is going to change things, but only for the odd powers. An even power isn't going to change because the reflection through the y-axis is symmetric, right? It's an even function. X to the second, x to the fourth, x to the sixth. We call that an even polynomial. So be aware, the right end and left end rules are very, very consistent, okay? Falling to the left, rising to the right when we have an odd highest power and a positive leading coefficient, and it's going to do the opposite. Once again, a reflection through the y-axis, where if I have a negative x cubed, for example, it's going to have to rise to the left and fall to the right. Once again, the right end behavior is to fall. The left end behavior is to rise. And this happens whenever we have a negative leading coefficient of an odd-powered polynomial. Okay? So once again, we now start to have this image happening. We have these polynomials which are always smooth, always continuous. No gaps, no holes, no jumps, no asymptotes. And they have no cusps, no sharp turns, no little corners, no things that get in the way or cause us to have a problem. The best way to think about that is trying to design a roller coaster. The last thing you want with a roller coaster is some point where the roller coaster might get stuck in between, or where the wheels are forced off of the track. Railroads are always working with a continuous and smooth type of structure. The wheels have to stay on the track, and it has to bend in a reasonable way so that it's not forced off and derails. Okay? So keep that in mind when you're trying to draw a polynomial. Make sure it is smooth, make sure it is continuous. Then you add into it the leading coefficient. Whether the leading coefficient is positive or negative will determine what happens to the right and to the left. We also have the degree of the polynomial, whether it is even or odd. Evens go in the same direction on the left and the right, whether that's opening up with a positive leading coefficient or opening down with a negative leading coefficient. And we always have with our odd degree polynomials going in opposite directions. So falling to the left and rising to the right when we have an odd power but a positive leading coefficient, and it will rise to the left and fall to the right when we have a negative leading coefficient. Okay? So these are the characteristics that we start with when we begin our process for working with polynomials. Next video, I'm going to be talking about multiplicity and how we put multiplicity in to graphing a polynomial. Thank you very much. I hope this is helpful. Please be well and take care. Bye-bye, Hornets.